This is R.D. Sharma Solution Class 12 Chapter 18 Maxima and Minima. Exercise is 18.3. Now before we go ahead to solve this question, my submission is that how our previous exercise or previous discussion, we have come to a simplified version of same solution. Previously, when we wanted to find out the maxima and minima, what we used to do? First thing, see, whenever we have certain function, there can be multiple maxima. There will be one maximum among all the maximas. That is why we call them as local maxima or local minima. There can be minima, multiple minimas also. There can be one top of them, but all others can only be called as local minima, local maxima. So what do? F prime x or f dash x, we differentiate the function. The second step we used to take was we used to equate it to 0. When we equate it to 0, we get the critical points. So we mark those points. Let us say we have 3 points and we mark it on the number line from negative infinity to infinity. And since this f dash x is equal to 0 gave us these critical points, we go on the left and right. That is, when we want to find out in the interval negative infinity to infinity, we go to the left of a. So if value is coming in the f dash x, if we put this value a, we are getting positive, we put positive. When we place b, we can get positive or negative like that. So we mark positive and negative on the number line. Okay. When we say we are going from positive to negative, we say that we were already on the upper side and we are going to the lower side. So we were on the maxima. That point was regarded as the local maxima. And similarly, the otherwise condition is when we were on the below part and we are going to say uphill. So we say that we were on the local minima. Then we find out the value a, b, c. We put the values and we find out the value of y on this a, b, c. After finding out whether these a, b, c are the local maxima or local minima point. Now, in this exercise or in this discussion, same thing we'll do. F dash x equals to 0 till this point and finding out the critical point. But we don't have to draw a number line and find out the values in these intervals, whether it is coming as negative or positive. Plus, minus, plus, all these we don't have to worry about. What we will do is, we will double differentiate this function. That is, one differentiation is already been done, we will differentiate it twice. For example, if we were having x cube, we will differentiate it f dash x. We will again differentiate it f double dash x, that will be 6x in this case. And then we'll put the value a, b, c. For example, if we take certain numbers, if I want to explain it with certain numbers, for example, we have negative 1, 2 or something like that. There can be multiple numbers. So if we have negative 1, 6 into negative 1 is what? Negative 6. Now I told you that at a, that is negative 1, previously we used to find out the value on the left and right. And then we see whether we are going from plus to minus or minus to plus. But here in the second derivative, if it is coming negative, it's clear that this is the point of local maxima. Negative means maxima. Let us take one more thing. If we get b as 2, we are getting 6 into 2 as 12. This is the positive value. So we don't have to go on the left and right of b. Rather than, because normally we, in the previous exercise, we got 7 pi by 4, 3 pi by 4. There are so many different kind of values a, b, c we got, and going on the left and right, it was pretty difficult to understand or to remember what will be the value of these trigonometric values. When plus is coming, we will say it is minima. And so negative means maxima, positive means minima. And it is not minima or maxima. What is it? It's local maxima and local minima. Again, refer to that graph. Now that theory which we just talked about, we'll apply it here and you will see that how easy it will become for us to actually say whether we get the local maxima or minima, and we'll find out the value as well. Fx is equal to x raised 4 minus 62x square plus 120x plus 9. Next one is the differentiation. So I'm differentiating it. 4x cube minus 62 into 2 is 124x plus 120. This is a normal differentiation. We'll take 4 common. X cube minus 31x plus 30 is equal to 0. 4 cannot be 0, so this has to be 0. Now equating to 0 of f dash x is mandatory. Now x is equal to 1. Let us put it here. When we put x equals to 1, we are getting this as 0. So x equals to 1, that is x minus 1, is one of the factor of this particular equation. We need more factors, so we will divide it. That is, we will divide this x cube minus 31x plus 30 by x minus 1. And you know already this difference, division, but for the sake of completion, I am going to tell you. X square will multiply, so x cube minus x cube will come, x square will come. Then let us subtract it. So x cube will be eliminated, x square will, I'm just shifting it on the left, putting this negative 31x and 30 on the right. Then just multiply it with x now. So x square minus x, again this sign can be changed, this gets cancelled. This is 30x, negative 30x plus 30. Now we need negative 30x, so we'll do what? We'll multiply it by 30, x minus 1 into 30. So we'll get minus 30x plus 30, change the sign, you'll get a 0. When you get the 0, that means we got x minus 1 as one of the factor and x square plus x minus 30 as the other part, from where we can devise what? The other two factors. So we have x square plus x minus 60, 30 can be 6 5 is 30 or 5 6 is 30. We can write it as 6x minus 5x. So now we can take this two factors, x minus 5 into x plus 6. So eventually this is all known to you, but for the sake of completion, these are the three factors. And I told you that we have to put it as 0. When you place it as 0 against these factors, f dash x equals to 0, that means x is equal to 1. You have to put all factors to 0. So x minus 1 equals to 0 is x equals to 1. X minus 5 equals to 0 is x equals to 5. And x plus 6 equals to 0 is x minus 6. Now we'll place this value. Normally we would place this value in the number line in the earlier versions. We'll take the values on the left and the right. We'll put the proper values, find out the sign. We'll check for the change in the sign, and then we'll say whether it is local minima or local maxima. But here you will see that we will double differentiate it. If you remember, this was our differentiation, first differentiation. I am going to again differentiate it. That is, I am going to differentiate this 4x cube minus 124x plus 120 again. It will give you 12x square minus 124. Now here we will place first of all 1, then 5 and then negative 6. In where? In the double differentiation. So when we put in the double differentiation, you will get 12 into 1 square minus 124, that is going to be negative. What will be the negative value? Minus 112. Now I am going to place 5 here. 12 into 5 square, that is 12 into 25 minus 124, that is going to come as 176. Negative 6 again, because it is negative 6 square, it will be plus. So 36 into 12 minus 124 is 308. I hope you got the idea. Now just see the sign. Negative 112 is maximum because it is negative. Local it is. I am just not writing local, but it is, these are all local. 176 is positive. That means it is local minima. 308 again positive. It is local minima. When we get positive, local minima. When we get negative, local maxima. The sign and the thing is different. Normally we say when it is negative, it is minimum. No, here it is inverted. Now what is the value for these 1, 5 and negative 6? We'll place this in the original function. So when I'm placing 1, it will be 1 raised 4 minus 62 into 1 square plus 120 into 1 plus 9. And this is going to give you certain value. That is the value of the function at x is equal to 1. At local maxima, what is the value of the function? That is y equals to fx. So this value will be the f1 value, which is coming from the original equation. So it will come as 68. Same way, we'll place 5 here. So 5 in the place of x, we are placing 5. 5 is 4 minus 62 into 5 square plus 120 into 5 plus 9. And that will give you negative, because see, these are the values which are coming from the original equation. Please remember, f dash x and f double dash x was just to check for the local maxima minima, but we have to find out the value also of the function. For example, f negative 6, if you put it, you will get minus 1647. When you place 5, it will be negative 316. So y is equal to fx. X is 1, 5 and negative 6. And that is how we got the 68, negative 316 and negative 1647. So this is the whole scenario. You can just pause it and have a look, or you can solve it by yourself. This is the whole scenario which we discussed. First, for fx, then f dash x, place f dash x equals to 0. You are going to get certain points which are the critical points. Now you don't have to go for the number line. Just take the double differentiation now. F dash x, double differentiation. When we are done with the double differentiation, now place these critical points 1, 5, negative 6 in this case into f double dash x. When you place these values, you are going to get negative or positive. If it is negative, it is local maximum. When it is positive, it is local maxima. And now once we have got this local maxima minimum value, now you have to find out the value of the function at these 1, 5 and negative 6. 68, negative 316 and minus 1647 will come. This is the whole scenario. This is the next question. And since we have just started the exercise, this question needs to be completed also, because normally if we are at the fag end of the exercise, I normally leave these type of questions because we have already done these type of questions. But here we have started, so we'll complete this question also. The first step is f dash x, differentiation. It will come as 3x squared, 6 to the 12, so minus 12x plus 9, for 15 will be eliminated. Now second thing will be f dash x equals to 0. We need the critical points. When we place it equal to 0, just you can take 3 common, because you can see 3 is common. X squared minus 4x plus 3. This x squared minus 4x plus 3 will give you the factors. So it will be x squared minus x minus 3x plus 3. You can take x common. It will be x minus 1 minus 3x minus 1. Eventually you got 2 factors here, x minus 1 and x minus 3. And when this is going to be 0, f dash x equals to 0 when x will be equal to 1 and x equals to 3. When you got x equals to 1 and x equals to 3, these value has to be placed in the double dash, double f prime, double prime x. That is, you have to differentiate the differentiation. Double differentiation I'm talking about. So f double dash x is 6x minus 12. This is the double differentiation. Now you have to place 1 and 3 in this double dash x, f double dash to f double prime. So f1 you have to find out with double differentiation, f double differentiation 3 you have to find out. So 6 into 1 minus 12, 6 into 3 minus 12, 6 minus 12 is negative 6, 18 minus 12 is plus 6. One time you got negative, so this is the point of local maxima. What is positive? It is the point of local minima. Local maxima, local minima you got. Now no graph making and no number line. Just place this 1 and 3 in the original equation in order to get the value of the function at these critical points. I am placing 1 first in the original equation, which is this. Now I am placing 3 in the original equation, which is this one. And these values are the actual function values. We'll get 19 in 1 and 15 in 3 when you place 1 and 3. Okay, so don't have to worry about the number line, don't have to worry about left and right situation. This is the whole scenario. So this is the reference in front of you. You can just pause it, have a look, try to solve it yourself. Next one is fx equals to x minus 1 into x plus 1 whole square. Now don't confuse here, because what you'll think is, oh, we already have the factors, we don't have to worry about anything. No, first we have to differentiate it. When we differentiate it, what does it mean? We have to take the differentiation. So rather than doing it like that, you have to take the multiplication. That is, you have to expand this particular fx. X minus 1 is already there, so I'll use the product rule for the efficient solution. I'm taken x minus 1, now differentiated x plus 2 whole square, next x plus 2 whole square, differentiated x minus 1. Now we can take x plus 2 outside, because this is common what we see. Inside you will have 2 into x minus 1, that is 2x minus 2. Inside this we have x plus 2, this can be x plus 2 here. Now what you see, 2x plus x is 3x, 2 gets cancelled. So what is the differentiation value, which is 3x into x plus 2. Better is to multiply inside, because we are going to go do the double differentiation as well. But when you put this equals to 0, the second step is f dash x will be equal to 0. This has to be placed as 0. When you place it equals to 0, this x will be 0 and x plus 2 will be 0. X, that will give you x equals to minus 2. So you have two critical points here, 0 and 2. Got the two critical points? The third step is to differentiate the differentiation. That is the double prime or double differentiation we have to do for 3x into x plus 2. That is why I was telling you that you need to multiply this inside. 3x square plus 6x. I'm differentiating it again. It will be 6x plus 6. 6x plus 6. Now what you have to do? You have two different values, critical values. So we'll have to find out f double dash 0 and f double dash 2. When you place 0 here, you'll get 6 into 0 plus 6. When you place 2, it will be 6 into 2 plus 6. First will give you 6, second will give you 6 to 12 plus 6, 18. Now both the time you have 6 and 18, that is the plus. When you have plus, that means, oh, there is a slight mistake. It's minus 2. What? That's my bad. So I'm going to put negative 2. 6 into minus 2 is minus 12 plus 6 is negative 6. So one time we got 6, other time you got a negative 6. Positive means local minima. Negative means local maxima. So in 6, see, this 6 and negative 6, we already got it. So I told you that you have to put this into the double differentiation value. We have placed it into 6x plus 6. This needs to be very clear. When we place 0, we got 6. When we place negative 2, we got negative 6. So positive means greater than 0 means local minima. Negative means less than 0, that is local maxima. Local minima, local maxima you got. Now we need to find out the value of the function at these critical points, which are what values? 0 and negative 2. So place this value 0 in f dash x. No, sorry, fx. Original equation. So fx, the fifth step is to take these critical points, place in the original equation. See, 0 minus 1 into 0 plus 2 whole square. So we can see here 2 square is 4, negative is already there, negative 1, so it will be negative 4. F negative 2 is negative 2 minus 1 and negative 2 plus 2 whole square. Negative 2 plus 2 is already 0. So when you multiply anything with 0 will be 0. So the first one f0 came down to negative 4 and the second one f minus 2 has gotten to 0. So we have negative 4 and 0. These are the value of the function at local minima and local maxima. And this is the whole process which you need to follow. This is the reference. This is a proper process you have to follow because you're going to write it as well. Logic, I told you, solution is your responsibility. You have to write everything because writing will make the examiner understand what you're saying. Next one is x greater than 0. You have 2 by x minus 2 by x square. So the first step is what? Find differentiation f dash x. When we do the differentiation f dash x, what are we going to get? See, differentiation is very clear to you. I don't need to remind you every time because you will say, oh, we can do the differentiation. But just for the sake of completion, it will be negative 2 by x square. Minus 2x square can be taken in the numerator. It will be x raised minus 3. Then you can differentiate it. Negative 3 will come in front. This 3 will go down as x cube. So what do you got? This is a simple differentiation I am applying. I'm doing nothing extra. First level differentiation. So what do you get? You can just take certain thing common if you want. 4 by x cube, or you can just replace or swap the places so that negative doesn't come in the front. I always deal with negative in between. That is what we have learned up till now. Second thing is f dash x has to be placed as 0. When you place this as 0, you will get the critical points. But what do you see here? X square is already there in the denominator. Why not to take the x square outside? 2 by x square can be taken outside. So this is 2 by x square. This is 2 by x inside. See, this is the way I am telling you. I am not binding you to follow this. It is up to you. You are intelligent enough. Okay, you are more intelligent than every one of us. So you can follow any way you want. So what I got is 2 into 2 minus x by x cube. See, the x is greater than 0. It is already given in the question. We cannot have x as 0. So 2 cannot be 0. Only 2 minus x can be 0. I am saying x is greater than 0. It is already given in the question. You cannot have x 0. 2 cannot be 0. So 2 minus x has to be 0. So 2 minus x equals to 0 is x equals to 2. So you got only one critical point, which is x equals to 2. When we got x equals to 2, what do we get? See, x equals to 2 has to be placed in double differentiation. So this differential has to be differentiated again. I am doing the double dash, that means double prime. I am differentiating it again. It will be x cube it's up to you. I always take this x cube and x square in the numerator, then follow the nx to the power n minus 1 differentiation, then I place that x raised negative to the denominator. So this is up to you. How do you do it? This is the whole scenario that you're going to find out. And then this in f double dash, we are going to place x as 2. So I'm now replacing x by 2 here. So minus 12 divided by this 2 raised 4, 4 divided by 2 raised 3. So when you simplify it, you can see that there will be certain value. This is, just let us simplify it by 4. So you get 3 by 4, and this is 1 by 2. 1 by 2 minus 3 by 4. So 4 minus 6 by 8. You get negative 2 by 8, that is negative 1 by 4. And we don't have to worry about value. We have to worry about the negative sign. Negative means local maxima. It's maxima. Local maxima. So when you got this local maxima, this is for the local maxima thing, but actual value can be only found from the original equation. So put this 2 in the original equation. 2 by 2 minus 2 by 2 square is 4. So you get 1 minus 1 by 2, that is 1 by 2. So that is half. So the value at this x equals to 2, y is equal to half. And we got at 2 the local maxima. This is the whole scenario. So now things are quite clear to you. This is how we are going to do it and write the content as per our requirement. Fx is equal to x into e raised to the power x. Now we have this fx and this x into e to the power x. The first step for finding the local minima and maxima with the double derivative. So we have to differentiate it twice. The first differentiation is mandatory in both the cases if you are using the first derivative or second derivative. So when we take the derivation or derive it, we'll use these product rule. So I'm using the product rule, and finally we got e raised x plus 1. Once we get this expression, the second step, this is the first step. The second step is to put this as a 0. That is e raised x plus 1 is equal to 0. So e raised x can be 0 or x plus 1 can be 0. When x plus 1 is 0, that means x is equal to negative 1, and e raised x cannot be equal to 0. Now you tell me, what is the value of e? E is a constant. It's 2.714 something. Any value, any number in the real set, if you place it, it's not going to give you 0 in any case. We are only left with x is equal to negative 1 now. This x is equal to negative 1 is the critical point, and this point you are going to get local minima or maxima. So the third step is double differentiation. So what do we got? E raised x plus 1 was the first derivative. We are going to get the second derivative. Again, this derivative is quite clear to you. Just use the product rule, f double dash x. So this x is to be replaced by negative 1. We are going to check the sign of double derivative at the critical point, which is negative 1. We get e raised minus 1, x plus 1. So I am replacing it by negative 1. Negative 1 plus 1 is of course 0. This one is eliminated. We get e raised minus 1, that is 1 by e. It is a constant. We are only interested in the sign, and this sign is positive. You are going to get the value which is greater than 0. When you have greater than 0, that indicates that this point x is equal to minus 1 is the point of local minimum or maxima. Minimum. Greater than 0, minimum. Less than 0, maximum. It's inverted in this case. Next one is fourth step. And the fourth step is the value of the function at x equals to minus 1, which is the critical point. So we got that x equals to minus 1 will be local minima, and what will be the value of local minima? It's going to be putting the x equals to minus 1 here. Now let me draw and show you that we have this x equals to negative 1. It will not be here. It will be on the left hand side. When we have on the left hand side this x equals to negative 1, this is x, and you are going to get y out of it. That y value will be found by putting x equals to minus 1 in the original equation, which is x e raised x. Y is equal to x e raised x. Now replace this x by negative 1. You get minus 1 into e raised minus 1, that is minus 1 by e. This is the final value. This is the whole solution in front of you. You can take it as a reference. Try it yourself. Any problem, just refer it. All these things you have to write by yourself. This is very important. Solving is more important, but most important is writing what you are actually explaining or doing. This question, x is greater than 0. We have already done a question like this. We have the function. We have to take the derivative. First derivative, and you already know the derivative, half minus 2 by x square. Next one is to place this as 0 or equate it to 0. 1 by 2 minus 2 by x square is equal to 0. So you'll get x square minus 4 by 2x square. I have just taken the LCM. When you take the LCM, this x square will be equal to 4. When you have x square equals to 4, that is plus minus 2, because under root 4 and this square can be negative or positive. It is going to get positive only. That's why plus minus both has to be taken. Now we have critical points, x equals to 2, x equals to minus 2. Now I'm doing something. You have to find that what wrong I am doing. I have to find the local minima or local maxima at x equals to 2 as well as x equals to minus 2. Next one is the double difference. And this 1 by 2 minus 2 by x square, 1 by 2 will get eliminated. Minus 2 by x square you can take in the numerator. It will be x cubed. So 3 will come in front and it is going to be, the 2 will come in front and this 2 minus 2 minus 1 will be x raised minus 3, and you can just take this in the denominator. Finally, you will get this 4 by x cube because it was already negative 2 by x square. When you have 4 by x cube, this is 2 and minus 2 you are going to check. I am still wanting you to check what wrong I am doing. Again, 4 by x cube, first put 2 cube and then replace x by negative 2 in order to get both the value. 4 by 2 cube, don't worry about the value, it can come any value, but you are worried about the sign. F double dash 2 will give you positive value, f double dash minus 2 will give you negative value. Positive is local minima, negative is local maxima. But the problem here is, in the question, it is already given x is greater than 0. When x is greater than 0, that means it's not taking x equals to negative 2. You need to stop at x equals to negative 2 when you start working with it. Because in question, it's already being said x can only be greater than 0, which indicates you can only take x equals to 2. You have to ignore x equals to negative 2. The value will be half for f double dash 2. That indicates it's a local minima, because positive means minima. See, I also get confused in minima and maxima because this is inverted. For positive, it's minima. For negative, it's maxima. The value of the function at 2 will be 2 by 2 plus 2 by 2. That is going to be 2. So local minima is by 2, and at 2, you get the value. This is the whole solution in front of you, and we have just ignored x equals to negative 2 because x is greater than 0, which is already given in this question. And all these things like f dash x equals to 0, then f double dash x, placing the value of 2, and then finding out greater than 0, less than 0. Next one is x is greater than or equal to negative 2. Let us see what value we get as the critical points. If they are not following this x greater than equal to minus 2, we will change it or will ignore certain things. First step is simply the differentiation f dash x, and you can just use the product rule for simple first derivative. Let me apply the product rule. That is, you have to keep the first one, differentiate the second one, then put a plus sign, then do the otherwise. That is, you have to put the second one untouched and the first one has to be differentiated. Okay, now what do you get? This differentiation is quite known to you now. I'm just doing it for the sake of completion, just to know that what you get is what I also show you, while if you are doing it commonly or with me only. So this is the differentiation, and I hope you are quite well versed with it. There will be certain negatives and positive going to appear, but our idea and our key is to find the local minima or local maxima. For that, we have to put this f dash x as a 0. Once we place this f dash x as 0, you can take certain thing common because you have this, or rather you can just use this expression and keep one term on left and the other term on right. This right and left, you will get this x plus 2 1 by 3, x plus 2 negative 2 by 3. You can take this on the left hand side and this is going to get added, because when this x plus 2 goes on the left, it will be x plus 2 raised to the power 2 by 3. And you know when the base is same, the power gets added. 1 by 3 plus 2 by 3 is just 1. So x plus what 2 you get here. On the right it is 1 by 3 x plus 1. Now just multiply this 3 with x plus 2. So you have this 1 by 3 x plus 2. Multiply both sides by 3. This is 3x plus 6. On one side, let us multiply negative also. On the right, it's x plus 1. And from here, we will get 1x value, and that will indicate that this is the point of possibility of local minima or local maxima. What it will be is still unaware. We get x equals to negative 7 by 4. Now imagine that finding out the local minima and maxima when you have negative 7 by 4 and not using the double derivative. In the previous exercise, we have seen that we have to go on the left and right certain values which goes on left and right of negative 7 by 4 and then find whether the sign is positive or negative. So it will become quite cumbersome in these kind of values. So the best way is to take the double differentiation. Now I am double differentiating it. I am going to write the actual value because double differentiation is going to take certain time here. And I know that your time is very precious. So let me write the second derivation because it will take some time to solve all this or to find out the second derivation. I am placing this second derivation in front of you. And now the next step is we are only left with x equals to negative 7 by 4. Now did you check this negative 7 by 4 is actually following x greater than equal to minus 2. Now you just have to take a guess. I mean, when you place negative 7 by 4 in x in f double dash negative 7 by 4, you are going to get greater than 0 or less than 0. Let me tell you, you are going to get greater than 0. And this value, when you place this, finally you are going to get x replaced by negative 7 by 4. And there will be certain values or there will be certain computation which I am showing you, and I hope that you will also be able to complete. But all in all, final value will be positive because 1 by 4 negative 2 by 3, 1 by 4 negative 5 by 2, they are same. They will never be negative. So we get for greater than 0, it will be local minimum. Minimum less means less than 0 means maximum. Greater than 0 means local minimum. Next step is to find out the value of the function at this x is equal to negative 7 by 4. Now just replace this negative 7 by 4 in the original equation, which is fx. fx, that is x plus 1 and x plus 2 raised 1 by 3. Now replace x by negative 7 by 4. That is the same thing I am doing and trying to find out the final value. This final value is this. You can refer what we just explained and see and find out and write also. All these sentences are to be made by you, are to be written by you, because the steps already you understand. We are on the 7th question right now. All the steps you are aware, only the computation part I leave it for you. But the final thing is, this is the whole solution, you can refer to it. And negative 7 by 4 is actually greater than equal to minus 2. How do you find it or conclude it? Because we have x equals to or greater than negative 2. Everything on the right is the value which is acceptable or admissible. But we got x is equal to negative 7 by 4. This negative 7 by 4 is actually, let me just divide and show you. It will come as this 4, 1 is 4, 3 and 7 4 is 28. Around negative 1.7 will come. And this negative 1.7 lies between, which is nearer to negative 2, but still it's above negative 2. So it's fair that we have taken this negative 7 by 4 and found out the value. fx is equal to x under root 32 minus x square minus 5 to 5. We have the interval being given x between negative 5 and 5. We will follow the same step that we have been following right now. First step will be the differentiation, f dash x. Differentiation, you can just use the product rule. Because we have already done differentiation, I'm going to write the differentiation, and I hope that this will be acceptable to you, because our idea is to find the local maxima and local minima. First, take the first one, differentiate the second one, then take a plus sign, put a plus sign, then do the inverse, that is, keep the second value, differentiate the first value. So this is what I'm doing right now. This is f dash x. The second step is to equate it is equal to 0. F dash x equals to 0. So I'm just making steps easier for me and just replacing this equals to 0 as equals to, because we have a negative sign in between. So when we put equals to 0, this both will be equated on left and right. Now you have under root 32 minus x square on the denominator and numerator of left hand side and right hand side. When they multiply, you get 2x square equals to 32. This x square will be 16, x will be plus minus 4. Now this plus and minus 4 should be in between the interval being provided by negative 5 and 5. You can just check it and I can assure you that these two both values are admissible, or you can say we can take both the values, or we have to take both the values in order to get the local minima and local maxima. The third step will be to find out the differentiation of the differentiation. That is the second derivative of the original function. First derivative we have already computed. The second derivative is only for the sign, to find out the local maxima or local minima exist or not and what are the values of it. The negative x, I'm just differentiating it. I'm just saying that this differentiation I'm going to write direct. This can be done because it will take certain time, and I have explained you that this is the time of short. People don't need all the explanation, they just need a hint, logic. So this is the logic. The logic is differentiation is up to you, and this is the whole differentiation, second differentiation which I'm writing right now. You can just verify it. This is the second differentiation, and now we have to check for 4 and negative 4. 4 and negative 4, f double dash 4 and f double dash negative 4. Just try to find out what will be the sign. Please remember, for double differentiation, we are not interested in the value. We have to do nothing with the value. We have to do with the sign. Sign is negative because f double dash 4 will come as negative 3. Negative means local maxima. Positive, that is 3, means local minima. Negative, maxima. Positive, minima. And when you get this, now you need to find out the value of the function at this negative 3 and 3. f4. F double dash 4 no. F dash 4 no. f4. This 4 and negative 4 has to go in the original equation. And since you see the square inside will be positive and negative in any case because it is being squared. And 4 and negative 4 outside, so there is only the difference of sign of f4 and f negative 4. f4 will give you 16, f negative 4 will give you negative 16. And up till now you have known that these are the value of the function at local maxima and local minima. First one is local maxima, the value is 16, local minima value is negative 16. So this is the reference of the solution I just explained. Differentiation is, I always say that this has already been completed, and differentiation is your responsibility. X cube minus 2ax square plus a square x. A is greater than 0. X belongs to real number. First step is f dash x. Differentiation of this function. It's 3x square minus, I'm differentiating it, minus 4ax plus a square. The first step is already done. The second step is to equate this f dash x to 0. When you place it as 0, it will be 3x square. You can make the factors out of it. And when we make the factor, then we get the critical point. This equating to 0 is only for the critical points where it can be found that local maxima exist or local minima exist. I am just making the factors. You can write this as negative 4ax as minus 3ax minus ax, and finally just put these two as 0 because any of these factors can be 0. From first we got a by 3, the second one we got x equals to a. Next step will be the double difference. The differentiation has already been done. The second one is the double differentiation, f double dash. We get 6x minus 4a. This is the only thing which we are going to. Now place a by 3 one, the second time place a, and then just worry about this sign. What is the sign you are going to get? Because this sign will tell you whether it is the local minima or local maxima. F double dash a by 3. Sometimes we also call it as f double prime, but you understand that when I say prime, it's derivative, double prime, it's double derivative. So now the value of the function we are not interested in. We are more interested in negative of 2a. Negative means you are going to get the negative value, which is indicating that this is the local maxima. 6a minus 4a is 2a. When you have 2a, that indicates that you are going to get the local minima. Negative, again and again I am saying, because the whole theory of this exercise is the value, not the value of f double dash, but the sign. Negative gives you local maxima, positive gives you local minima. The only thing which is left is to find out the value of the function at these two values, which is a by 3 and a, which also is considered as the critical value. Original function you have to use. Please remember f prime, f double prime, leave it now. We have to go back again to the original equation and replace x by a by 3 and a. And what are the values you are going to get? I hope that you are quite aware now that what we have been doing. It's a cube minus, I'm placing a for the first time. A cube minus 2a cube plus a cube is 0. When we place a by 3, the value is going to come as 4a cube by 27. So these are the values. This is the reference for you, because all those things which you are going to write is, this is fx is equal to x plus a square by x. Here a should be greater than 0, first requirement. The second requirement is x should not be equal to 0, or this is the condition also. Requirement plus condition. The first step we generally take in local maxima and minima is the differentiation. We are taking the differentiation, that is f dash x we are taking. So this 1 plus a square and 1 by x differentiation is negative 1 by x square. So I have already placed a negative here. Second step is to put or equate f dash x to 0. This f dash x equals to 0. That means 1 is equal to a square by x square is equal to a square. This gives x will be equal to plus minus a, because we have two values here which are the probable or possible points of local minima and local maxima. So this plus and minus, local minima, local maxima. This next step what we take here is to double differentiate. The double differentiation of 1 minus a squared by x squared. We are going to differentiate it again, and since 1 is going to be 0, negative a square by x square, this x goes up, negative 2, and this gives you negative 2x raised minus 3, negative 2 by x cube, and since already there is a negative, the whole result of f dash or f double dash, as you can call it as double prime also, f double prime, and this goes a square by x cube, and this a square by x cube. Please remember a is greater than 0 and x is not equal to 0. Next thing comes is, because these are the critical points, and since a square by x cube, since we have a variable here, one time this variable will be replaced by a, another time negative a square by a cube and a square by negative a cube. Both the time you will get 1 by a, f a with positive 1 by a, f negative a by negative 1 by a. And since it is positive in first case, it's greater than 0, that indicates that you are going to get local minima. This is local minima, positive local minima. And since we have this as negative, you are going to get negative 1 by a here. These are all the cancellations I am doing in front of you. But whole idea is negative 1 by a is less than 0. Less than 0 simply means it's local maximum or local maxima. So we have already found the local minima maxima point at the critical points plus a minus a. Next step is to find out the actual value of y for fx. In this case, x is a and negative a. We have f a and f minus a in the original equation, that is x plus a square by x. So I am replacing in the first equation, basic equation, the question equation, a and negative a. And simply you will get, this is cancellation 2a, this is going to be negative 2a. Minus a, this gets cancelled. Minus a is minus 2a. We have 2a by negative 2a. And this is the value of local minima and maxima at these critical points of local minima and maxima. So I hope you have a clear understanding here what we are doing, and the next question will also follow the same scheme. Again, these are the content which is to be written, because the writing is more important than you knowing how to solve it. Answer is with the all writing. Okay. Now x under root 2 minus x square. This x should be between negative root 2 and positive root 2. Differentiation is all clear to you. I don't need to tell you again and again, because differentiation we have already done quite a number of times. I'm writing the differentiation. You just have to take the product rule. Once you do this, the second step is f dash x has to be equal to 0. When you place or equate this as equal to 0, this both equal to 0, one will go on the right hand side. So let me do it here only. It will be is equal to. That is, when you have this under root 2 minus x square multiplied, 2 minus x square is x square, 2x square is 2, x square is 1, x will be equal to plus minus 1. X is plus minus 1, that means you have critical points as plus and minus 1. But negative root 2 and root 2 is 1.414. So we are still inside this above said interval. Next step is to find out the double differentiation. We are going to differentiate what we have differentiated earlier. So this is going to be the double differentiation or second derivation. And this is done only for the finding out of the sign at these critical points. That means if I write the double differentiation, it is going to be negative x divided by under root 2 minus x square. And since we have done all the differentiation, a whole chapter we have completed, that's why I am writing it, because this is the differentiation of the differentiation. It is not the original differentiation. And we just have to replace the plus 1 and minus 1 and try to record the sign. What sign, plus or negative, you are going to get. Let us place it here, plus 1 and minus 1. F double dash 1 and F double dash negative 1. This 1 and minus 1, and you can also estimate rather than actually solving it. Just try to find out what sign is going to come. As I said earlier, we are not interested in the value, but instead in this sign. F double dash 1 gives you negative 2, that is less than 0. F double dash or double prime negative 1 is 2, which is greater than 0. Negative 2 is local maxima. Negative always gives you local maxima point, and positive will give you local minima point. This is local maxima and local minima. Next step is just to find out the value of the function at these critical points. There is nothing with regards to step 3 and 4. 3 and 4 step is only for the sign, knowing the sign. This fifth step can also be done just after the second step, because once you are aware of the critical points, f1 and f negative 1 has to be placed in the original equation. This original equation, that means we are replacing x by 1 and then negative 1. You can see here I am writing 1 and negative 1 here, and that those values are the actual value of the function at these critical points, which is of course the y point, because y is equal to fx. Fx is the function we are talking about. Y is f1, y is f negative 1. Again, third and fourth step you can just ignore. We don't need to do third and fourth for this, but just for the sake of local minima and maxima we have done it. So now you have known the values. These differentiation have already, because we have already computed it. So just I have written for sake of completion. Otherwise I leave it for you. Next one is x plus under root 1 minus x. X should be less than equal to 1. That means we will check for the value. If it is less than 1, we are going to ignore it. The first step is a differentiation. So we have differentiation 1 by twice of under root 1 minus x, and this is quite clear to you. The second step is simply equating it to 0. Just equate it to 0. I'm writing it here only. This is the whole LHS and RHS, left hand side and right hand side. On either side, twice under root 1 minus x is 1. Under root 1 minus x is half. Now you can square it. 1 minus x is 1 by 4. X will be equal to 1 minus 1 by 4. And 1 minus 1 by 4 is simply 4 minus 1 by 4, that is 3 by 4. X gives you 3 upon 4. This is the critical point, and on this critical point we have to check for the local maxima and minima. For that, this third step is mandatory, and this is the double derivative way of solving this question. Double derivative is simply f double dash x. 1 minus 1 by 2 under root 1 minus x has to be differentiated, and since you are already aware of the differentiation, quite often you have done it, this is the double differentiation. Once this is completed, we have to put x equals to 3 by 4, which was computed by f dash equals to 0 when we placed it. This x equals to 3 by 4 has to be replaced in f double dash or f double prime 3 by 4. When you place x equals to 3 by 4, in the third step, you are going to get a negative half. Negative half is simply a negative number, and this negative number, that is less than 0 number, indicates that this is a local maximum point. Local maximum point. This is the fourth step, but the final step can be, third and fourth can be bypassed if you are not asked about local maxima or minima. But once you are aware of the critical point, you have to find out the value of the function at the critical point. And this is by y equals to fx. Replace x by 3 by 4 in x plus under root 1 minus x, which I have done. It will be 5 by 4. This is the step-by-step solution of what I have just explained. English language is very important when you are writing, and this concludes that what you know. This is a repeated question, and this question we have done multiple times. And since we have done it already, you have to multiply it first, then you have to differentiate. And this is I am placing in front of you because this is almost similar to the previous question we have completed. Next one, x under root 1 minus x square. This question also is indicating that we have already done. Since it involves a lot of differentiation, this question also is being completed. But I'm going to explain it to you here itself, because doing it will be the waste of time for those who are actually following all of my videos or all of my discussion. And this is the f dash x first of all. This differentiation has to be equated to the second step. Has to be equated to 0. You will get 1, negative 1 and negative 1 by 5. Once you get these three critical values, you have to find out the double dash x, that is the double differentiation. Once you do the double differentiation, you are going to get certain expression. And in this expression, 1 by 1, we have to replace it x by 1, negative 1 and negative 1 by 5. When we replace 1, you are going to get what? I am saying f dash is already computed. F dash x equals to 0 gives us the critical point. F double dash x, here we have to place 1, negative 1 and negative 1 by 5. And then you see at x equals to 1, we get 0. And whenever we get function, double dash function value as 0, simply you can say that this is the point of inflection. Since less than 0 and greater than 0, less than 0 and greater than 0 is what gives you local maxima, local minima. But when you have 0, f double dash x equals to 0, negative and positive is nothing. That means you can just say it is a point of inflection. As you remember, negative gives us local maxima, positive gives us local minima. So f double dash x equals to 0. This is the first question we are talking about like this, because point of inflection in the double derivative scenario has never come. And this has come now. Final value has to be computed in the original equation. Now just place x as 1, negative 1 and negative 1 by 5 in the original equation, and then find out the value of the function at these critical points. And you don't have to find out for 1 because this is a point of inflection. Don't worry about placing 1. Just negative 1 and negative 1 by 5 has to be computed. That is f negative 1 and f negative 1 by 5. Local minima at f double dash negative 1, and that is the point negative 1. Negative 1 by 5, you are going to get local maxima. So this is the whole scenario. I would really encourage you to do it by yourself. Only differentiation is the key here. This is a different kind of question and we are going to attempt it. And you don't have to do anything here, what we have discussed earlier. Since only differentiation has to be done and extreme values are already given. Extreme values here are indicating just the critical points which I have been talking about. I have been talking about the critical points which are gained by placing f dash x equals to 0. F dash x is equal to a by x, log x is of course 1 by x, b x square is 2x and x differentiation is 1. This is f dash x. Now, the next thing comes here is we have to place the 1 and 2 because this is the critical points. And critical points will give you f dash x equal to 0. That means placing 1 in the differentiated equation, placing 2 in the differentiated equation has to be equal to 0 and that will give you a and b. How? Critical points already known to us. Extreme values, critical points already known to us. X equals to 1, x equals to 2. So now just take x for 1. This is a by 1 plus 2b into 1 plus 1 equals 0. From here we'll get an expression a plus 2b plus 1. So I'm taking this negative 2b and negative 1 on the right. Now I'm placing in the differentiated equation first derivative 2. Once I replace x by 2 here, a by 2 plus 2b into 2 plus 1. We again get an equation here. Again a is equal to negative 8b minus 2. And these two equations will give you a and b because we have two variables and two equations. We don't need any other equation here. Let us solve this. Minus 1 minus 2b is equal to minus 2 minus 8b. Take b content one side and other constant values on other side. We get 8b minus 2b as 6b. On the right you will get this as negative 1. B is negative 1 by 6. Now this b equals to negative 1 by 6. Replace it in any of the equation 1 and 2. And from here you are going to get a. We will get a here. So this a and b are the values which are asked in this question. B is negative 1 by 6. A is a negative 2 by 3. This is the local minima, local maxima not question. That is, it is not related with local minima maxima. It's something different. And especially for the critical points I'm talking. What are the critical points at which the f dash x equals to 0? F dash equals to 0 is all about the slope of the line. Slope has to be, because this slope when it is parallel to the x-axis, then we say dy by dx is 0. Because a line which is parallel to x-axis or it is x-axis, then only the differentiation should be 0. F dash x or f prime x is nothing but the differentiation only. So this is how you're going to do, and these are the very simple steps that you can follow. Show that log x by x has a maximum value at x equals to e. Now x equals to e, it is having a maximum value. First step is to differentiate. We will find out the f dash x, that is f prime x, and differentiation you already know how to do this. You can take p by q form or the question form to take the differentiation. Denominator goes square, then the denominator. Differentiation of the numerator, which is the log x is 1 by x. Subtraction, then the numerator and the differentiation of the denominator. Denominator is x, so the differentiation will be 1. Now this will become 1 minus log x divided by x square. 1 minus log x by x square is our final differentiation. In order to find out the local minima or maxima, we will take this f dash x and equate it to 0. So when it goes, x square will be 0. 1 minus log x is going to be 0. So that simply means log x is equal to 1. When we say 1 minus log x equals to 0, that is 1 is equal to log x. And we already know in terms of log or wherever the log properties comes, log base ab equals to c. This means a to the power c is b. So if base is e, then e raised 1 is equal to x. That means x is equal to e or e is equals to x. This is the critical point for x. The third step comes is the differentiation of the differentiation, that is the double differentiation, f double dash x. And then this f double dash x, after doing the differentiation which I am right now writing, I am not doing it and I hope you will be able to do this differentiation, because differentiation is a piece of cake for you now. This f double dash in place of x, we are going to replace it by x is equal to e, because the critical point was x equals to e. And in order to show this as maximum value, we have to show that this value is going to come as negative. That is, we will replace x in the f double dash x, the double differentiation, and when we see it will come as minus 1 by e cube. And e is a constant value, it cannot be positive or negative. But this negative 1 by e cube will definitely be negative. Why? Because 1 by e cube cannot be negative. So this is less than 0. And once the double differentiation is less than 0, that indicate that we are talking about the maximum value at x equals to e. And this is the local maxima when we placed x is equal to e, which we got when we were finding out the critical points. So this is how we have proved that this is x equals to e, double differentiation. We placed x equals to e in the double differentiation value, and the value is negative. So this is the reference which you can follow, and you can solve it. All these sentences you have to really know and write. Find the maximum and minimum value of the function fx is equal to 4 by x plus 2 plus x. First step, f dash x, differentiation of this function. Let me write this. Normally, actually the differentiation is quite known to you. So I'll write the differentiation, because normally x plus 2 should go up, or you can do it by quotient rule. So this differentiation is done. Second step is to place this f dash x is equal to 0. That is, we have to place it as 0. So we are equating this negative 4 by x plus 2 whole square plus 1 equals to 0. What do we get? 4 by x plus 2 whole square is equal to 1. X plus 2 whole square is equal to 4. And x plus 2 is equal to plus minus 4. Alright? It's not plus minus 4, it will be plus minus 2. I'll just change it. There's a slight change, I'm going to do this. So when it is 2, because x plus 2 whole square is 4, that means x plus 2 whole square is plus minus 2. So plus minus 2, so this 2 will go on the right, one time plus, one time negative. So one time you will get 4, one time you will get 0. Alright? So this is negative actually, but because minus is already there on the right. So negative will go on the right and it will become x is equal to negative 4. So you got 0 and negative 4 as the critical points. And these critical points are the point of possibility of local minima or maxima. These are the points. So we will find out the double differentiation. In order to check whether maxima or minima, these points are there or not, or these points signify minima or maxima, we'll do the double differentiation. So 8 by x plus 2 whole cube is the direct double differentiation which I have written. And since there is no interval being given here, there is no say domain or range, etc. So we will check at 0 and negative 4. We can take both the values. So we have to check for f double dash 0, and we need to check for f double dash negative 4. And we will place this 0 and negative 4 in this 8 by 8 plus 2 whole cube. So one time just place 0, the other time just place negative 4. So 8 by 2 cube is 1 only, because 2 cube is going to get cancelled. So f0 is going to be 8 by 8, which is 1. How about negative 4? When we place negative 4, it will be 2 minus 4, that is minus 2. Minus 2 whole cube will be negative 8. So one time you will get 1, one time you will get negative 1. So 1 means greater than 0, it is indicating local minima. Positive always indicates local minima. But negative value in minimum, opposite of minimum is maximum. So the value which is going to be negative will be oppositely matched. Greater than 0, local minima. Less than 0, because we have got negative 1. This is going to be local maxima. So we have to find out the maximum and minimum values which we found here. Okay. Now this 0 and negative 4 has to be placed in the original equation. In order to find out the value of the function at these critical point, we have to place the 0 and negative 4 in the original equation. When you place 0, it's going to be 2. So you can say f0 is equal to 2. And when we place negative 4, it will be 4 by negative 4 plus 2 minus 4. So this is negative 2 and this gets cancelled, 2, 2. So negative 2 minus 4. So you are going to get negative 6 here, which is the value which we have here also. This is the whole explanation also, and for reference who are doing it by yourself. So this is a slight thing which you can ignore. Other things remains the same. So you just know how to write so that you can complete this question. Writing. Find the maximum and minimum value of y equal to 10x minus 2x. F dash x we are going to find out. 10x is sec square x minus 2x, so minus 2. And then second step is f dash x should be equal to 0. Let us place it as 0. So sec square x will be equal to 2. So sec x will be equal to plus minus root 2 that we are witnessing, that we are going to get. So sec x, or if you are aware of, or if you are well versed with cos x, you can write it as 1 by cos x also. So sec x will be plus root 2 one time, and sec x will be negative root 2 one time. These 2 points are the critical points. These points, critical points, have to be checked. For what? F double dash x. First thing is sec x can be 1 by cos x. Cos x is 1 by root 2, and you know it is pi by 4. Sec x is negative root 2. 1 by cos x is, or cos x is minus 1 by root 2. That only comes when it is pi minus pi by 4. That is 3 pi by 4. So we have pi by 4 and 3 pi by 4. These are the 2 critical points, possible points where you can get the maxima and minima. F double dash x we have to find out. That is, we have to again differentiate the sec square x minus 2. 2 will be 0, of course. Sec square x will be 2 sec x, and then differentiation of sec x will be sec x tan x. So this is 2 sec square x tan x. 2 sec square x tan x. And the fourth step is f double dash pi by 4. F double dash 3 pi by 4. These are the 2 values, critical point value, possibility of maximum and minimum. Now this can only be found using the double differentiation. And double differentiation, 2 sec square x tan x, just place x as pi by 4 in the first case. In this, just replace it by 3 pi by 4. So this 3 pi by 4 will come. And you know already that the values of 10 pi by 4 is 1. 3 pi by 4 is negative 1. Similarly, here sec square x is there. So whatever is the value is there, negative or positive, it is going to come same. So the only difference is 10 pi by 4 and 3 pi by 4, which will give you 1 and negative. So the values remain the same. Only the sign will change. So 2 sec square pi by 4 is 1. I told you it was root 2. So 1 by root 2, this root sec square, if you do root 2 whole square, is 2. So you got 4. It is local minima. Here you will get negative 4. It will be local maxima. Please again understand, the greater than 0 or the positive value indicates minima, local minima. And the negative value will indicate the local maxima. So tan 3 by 4, let me take you to the actual geometric points. Tan pi minus pi by 4, add sugar to coffee. When you have add sugar to coffee, this second quadrant will have tan as negative. So that is why it is negative. Tan 3 by pi by 4 can be written as tan pi minus pi by 4, or you can simply say tan 135 degree is minus 1 only. Negative is less than 0, and that means local maxima, local minima, local maxima. Now we don't have to worry about these values because these are just for sign, but we have to worry about pi by 4 and 3 pi by 4 because these are the critical points where actual values of the function has to be computed. So we have y equals to 10x minus 2x, tan pi by 4 minus 2 pi by 4, and the second value will be tan 3 pi by 4 minus 2 into 3 pi by 4. Tan pi by 4 is 1, tan 45 degree is 1, 2 into pi by 4 it can be pi by 2. 1 minus pi by 2 you can just write, this is the final value of the first critical point. The second critical point 3 pi by 4, again just place it in tan 3 pi by 4 minus 2 into 3 pi by 4. Tan 3 pi by 4 is negative value, and 2 into 3 pi by 4 just cancel this 2. So 2 cancelled with the denominator, it will be 3 pi by 2. So negative 1 minus 3 pi by 2 is the second value. So this is how you are going to solve it. All the steps are being given. Whatever I have explained is in front of you. Just try it by yourself because mine is logic, yours is writing. X cube plus ax square plus bx plus c has maximum at x equals to negative 1, minimum at x equals to 3. Determine a, b, c. So minimum, maximum is already given. The critical points are already given. And at this critical point, the function has to be 0. So we'll first find out the f dash x because the f dash x has to be 0 at these critical points. So I'm differentiating it. This is the differentiation 3x square plus 2x plus b. Next one will be the minus 1 and 3 value. These two values will make this differentiation 0. That is how we come to the critical points. How do we compute the critical points? By placing the equation equal to 0. So these are the value we have got after placing the equation, the first differentiation equation as 0. So f dash minus 1 is equal to 0. f dash 3 equals to 0. So take the differentiation expression, put minus 1 in it, and find out the equation. There will be an equation being formed. Again, place the value 3 in place of x and see what value comes. So 3 negative 1 whole square plus 2a into negative 1 plus b is equal to 0. So this equation will be simply this 3 minus 2a plus b is equal to 0. The next, this equation is there. The second equation will be by placing 3 in the differentiated equation. 3 into 3 square plus 2a into 3 plus b. So this was actually equal to 0. This is 3 9 3 27 and 6a plus b. So we have two separate equations, and you see we have 3 variables but we have 2 equations. There is no way we can find out the third equation, or we can come up with the third equation. So let us deal with these 2 equations and try to find out what can be the values a and b can be found out. Okay, now I have just re-verified it and just subtract these 2 equations. When we subtract this b gets cancelled. 27 minus 3 is 24 and 6a minus 2a is 4a. So we have 24 equals to 4a. 8 it was negative 2a. Okay, please remember that is why it became plus. So you have to subtract 6a plus 2a, it will become an 8a. So a is equal to minus 3. Now place this a equals to minus 3 in any of these 2 equations. When we write a equals to minus 3 in either of the equation, for example, I am writing or replacing a equals to minus 3 in the first equation, we get 3 plus 6 plus b equals to 0, which gives b is equal to minus 9. A, B, C. There is no way we can find out the value of c, because the number of equation decides how many variables can be solved. 2 equation, 2 variable. 3 equation, 3 variable. Where is the third equation? There is no third equation, or we can also not come up with the third equation. I hope you got the idea. So you can just write that c is belonging to real number, because any number can only belong to real number, because there are different subsets of real number. Real number is the biggest set. That is why we have a and b, minus 3 and b equals to negative 9, but c cannot be found, and this is simply belonging to real number. So this is the minimum maximum at negative 1 and 3. This is the main key point here, which tells us that we have to take the differentiation, equate it to 0, and this will only come 0 when we have 1 and negative 3. Sin x plus root 3 cos x has a maximum value at x equals to pi by 6. This means the maximum value at x equals to pi by 6, the differentiation of this equation, when we place x equals to pi by 6, it is going to give you 0. This is the only justification of this question, and that is the solution also. Fx is there, just take the differentiation f dash x. When you take the f dash x, it will be cos x, and cos x will be minus sin x, cos x minus root 3 sin x. Now second step is to place f dash x equals to 0. Now it is already given in the question that as x is equal to pi by 6. This is the critical point already being given, and already given that it will give you maximum value. So we will place pi by 6 here, and since it is maximum value, we don't have to worry about anything. We just have to take the double differentiation, and since we have to prove, we'll take the double differentiation and we'll place this pi by 6, and we will say that we are getting a negative value. What I am trying to suggest here is double differentiation has to be done. We don't have to place f dash x equals to 0 in this case, because double differentiation is minus sin x minus root 3 cos x, and in the place of x in the double differentiated equation, we will replace it by pi by 6. Once we replace it by pi by 6, we will like to know whether the sign is negative or positive. If it comes as negative, it will be maximum. So let us see. Sin pi by 6 minus root 3 cos pi by 6. Pi by 6 is simply 30 degree. Sin 30 degree, and here cos 30 degree. And these values are quite known to you. It is half. Sin 30 degree is half. Cos 30 degree is root 3 by 2. So we have minus half, and minus you can take common. Half minus root 3 becomes 3. 3 by 2. 3 plus 1 by 2 is 4 by 2, that is 2 gets cancelled. You get negative 2. So negative 2 is less than 0. And this shows this minus 2 is less than 0. Negative means we will have the maximum value. And that was we were interested in. We wanted to show that it is negative. And same thing is being done here. Only double differentiation and putting this pi by 6, we will tell you that it is negative, and negative means point of maxima. So this is all about this exercise. Thank you so much. Take care of yourself.